Afternoon. Okay.
A very good afternoon to all of you. I am Kavita Jaiswal. I am going to host today's session. On behalf of Department of Computer Science and Engineering, NIT Raipur, and 4th International Conference on Machine Intelligence and Signal Processing, I welcome all the respective session chair and participant. Before we start the session, let me introduce our esteemed session chairs. Our first session chair is Dr. Neeraj Kumar Rathore. Dr. Neeraj Kumar Rathore is presently an associate professor in the Department of Computer Science and Engineering at Indira Gandhi National Tribal University, Amarkantak. He has completed his PhD from Thapar University, Patiala in the year 2014. He has published several articles in peer-reviewed essay journals, international national conferences, and book chapters. His research interests include cloud computing, machine learning, database management system, data structure, algorithm, etc. Thank you, sir, for accepting the invitation and joining this session. Our next session chair is Dr. Subhajit Ghosh. Dr. Subhajit Ghosh received his PhD degree from IIT Kharagpur in the year 2010. He has more than 19 years of teaching experience at BIT Mishra, NIT Rourkela, and NIT Raipur. Presently, he is working as Associate Professor in the Department of Electrical Engineering at NIT Raipur. He has published more than 75 papers in different SGI journals from reputed publishers like IEEE, Elsewhere, Taylor and Francis, Wheeley, and Springer. He has handled research projects worth more than 1.3 crore from different funding agencies like DST, CCOST, SERB, and DRDO. He is presently involved in an international project on renewable energy with North Carolina State University. He was awarded the Best Faculty Award of NIT Raipur for the year 2020 and 2021. His research interests include optimization technique, control system, renewable energy, and machine learning application. Thank you, sir, for joining this session. Our next session chair is Dr. Avinash Pujari. Dr. Avinash Pujari has completed his PhD from NIT Raipur in the year 2021. He has published several articles in peer-reviewed essay journals, including IEEE Transitions on System and Cybernetic System. He is also an active reviewer of reputed journals. During his PhD tenure, he had also received the prestigious Shiksha Gary Mahajan Travel Award to attend the ACM Races Summer School 2019 at Gothenburg University, Sweden. He also has academic experience at various organizations, including Sambalpur University and Bennett University. He is currently working as an assistant professor in the Department of Computer Science and Engineering at SRM University, Amaravati, Andhra Pradesh. Thank you, sir, for accepting the invitation and joining this session. Now let's begin the paper presentation. Before we start the presentation, there are a few instructions for the participants. Each participant will get 10 minutes for the presentation, out of which last 2 minutes is for question answer session. So I request all the participants to follow the timeline. And also I request all the session chairs and participants to keep their video on during the session. Here in this session, we have 5 papers to be presented. I request to session chairs to start the session. Over to session chairs.
Okay. So let's start from the first paper. That is paper number 106, a clustering and top-sys basis development ranking model for decision making in software bug tracking. His author is Pawan Rathoria and Rama Ranjan Panda and Naresh Kumar Nagwani. Is here?
Yes, sir.
Yes, sir. Yes, sir.
You may start, sir. You may start your presentation. As already declared that total 10 minutes time and in which 2 minutes for the question answering.
Yes. Sir, my screen is visible?
Yes, yes.
Hello everyone.
Yes, it is perfectly visible.
Hello everyone. Good evening. Myself Pawan Athuria. My paper ID is 106 and the paper topic is clustering and topics based
Other
developer.
person may mute your mic. Please,
Yes,
other person.
sir. Actually, I am sitting in the lab. Okay. So there is an outline. So first we will discuss the introduction. Then we will discuss the purpose methodology. Then we go through the design, and after that we will do the conclusion and
Other
future.
person,
After
rather
that,
than
we will
presenter, please mute your mic. It will.
So let's come to the introduction. So as we know, in the field of software engineering, testing software and bug fixing is a key activity. In large-scale software development, bug fixing is a real challenge to address.
Pawan, the sound is coming from your end only. We are not able to hear anything. The onus is on you to make it clear. So please do something.
Okay, sir. I am checking my network setting.
No, it has not to
There
do
may
with the network. It is because of the sound that
There
is
is,
coming.
Pawan, there is lot of noise coming from your end.
actually, ma'am,
Background
I
noise.
living. Okay. Okay. So in the field of software engineering, testing software and bug fixing is a key activity. In large scale software development, bug fixing is a real challenge to address. What bug fixing? Bug fixing is the process of assigning the newly reported bug to the most suitable developer who fits the criteria to fix the reported bug. And it is very challenging task if we do it on a large scale. And there is a lot of work are done by other authors using machine learning algorithm for automated. But the problem with that approach was they does not consider the ability of the developer, and there is also drawback of the bug sourcing, and they also use the sometimes textual data. This leads to inconsistent result. To hence to overcome that all problem, we proposed a multi-attribute criteria decision making model adopts for by considering the ability of the developer. So let's go to the proposed methodology. So our methodology will be happen in seven parts. First we will extract the bug from the bug history. After that we will apply the some pre-processing task. And after that we will go through we will make a developer vocabulary and we will also generate the metadata generation. And after that, whenever newly reported bug will come, we will match its developer vocabulary with other developer, and based on the similarity, we will filter the developer. And for filtered data, we will only extract the metadata which are already generated in step 3, and after that we will apply HP method, and after that we will apply the top for ranking of development. So if we're going ahead, there are the mainly two methods are using HP and the so HP stand for analytic hierarchical process, and it is used for selection problem, and we can also use in ranking. But now we are only using it for calculating the weight of the criteria. In our case, the weight are, and as we will discuss in by flowchart. So first step, set up the criteria. So for example, set up the criteria. We are selecting the developer. So for that, the criteria for selecting the developer, like the experience of the developer on how many bugs he has been sold and what is the average shipping time. And after selecting the criteria, we will make a pairwise performance matrix in which it will contain the relative importance of the criteria. After that, we will calculate the weight, and after calculating the weight, find we will multiply that weight to find the weighted sum, and after that we will find the lambda max and consistency index, and if we will also check the consistency if it between 0 and 1, the product and similarity to the ideal solution. So in first step, we will create a decision matrix which will contain the in first step, we will get a decision value of the criteria which are already taken from the HP method, and after that we will normalize the matrix. And after normalizing the matrix, we will multiply the weight which are calculating using HP method, and we will de determine the weightage normalized matrix. And after that, we will find the determined positive ideal solution, and we will also find the negative ideal solution. So what is the positive ideal solution? A positive ideal solution is generally uh, uh, criteria which solution is a positive. For example, in case of developer, the criteria is experience. So the positive added solution is the which has the highest value for experience. And similarly, in case of negative added solution, if we want, in some case, if we want to decrease the criteria value, for example, in case of the average fixing time, so we will take it minimum value. Hence, we will after finding both positive and anti-ideal ideal and anti-ideal solution. And after that, we will find the closeness ratio, and based on the closeness ratio, we will rank the developer. So here is the overall architectural proposed algorithm, and the first step that is a bug repository, and in bug repository, we will extract the developer summary, and after developer summary, we will pre-process that, and where new will come, we will also pre-process that, and after that, we will compare the developer summary with the new bug report, and by that we will filter the developer, and this output will be given to the extract developer metadata, and we will also extract the criteria which we will already discussed, and we will also find the, and after that we will use a SP method for calculating it, and for filter developer we will apply the toxis method, and we will get the result. So it is some case study which I include. For example, there is a criteria pairwise comparison matrix which will be input for the HP matrix, and here EARNT, there is a abbreviation. E stands for experience in year, A stands for total bug assigned, and for newly assigned bug, R for total resolved bug, T stands for average fixing time, timing in a day. And after applying the HP method, we get the weight of all the criteria shown in table C. After that, we will in Topsys method, there is a developer performance metric, and this value are the metadata which will be extracted from from our bug repository, and there are the 5 developers, and this value are based on the criteria, and after applying the Topsys method, we get the closeness ratio, and based on them we will rank the developer for the bug pricing. So conclusion, clustering and Topsys MDM techniques utilized for bug pricing. The precision approach also considers the availability of software developer while assigning the newly reported bug. The expert developer are selected by using the hybrid technique of HP and Topsys model. In future, we will also calculate the performance of the ranking model using precision at K, recall at K, like MAP, DCG or NDCG. And we can in future we can also apply the other MCDM algorithm for effective routing of development in bug pricing. And these are the some of the weaknesses. And thank you.
Thank you, Pawan. Is there any question from the participant side? Anybody ask any question to Mr. Pawan?
34. 34.
Hello, yes.
Okay, are you sitting? 36. 37.
Sir, I have one concern regarding Pawan.
Yes,
Yes, sir.
31.
So you have mentioned about obtaining the precision and all those NDCG values. So how you are going to find out the ground truth values for the same?
Actually, sir, what sir? I did yes, sir. Actually,
This one. Conclusion.
Yes, sir.
Conclusion.
Wait, sir. Okay. Sir, conclusion. Okay.
So in the third sentence that you have written.
Yes, sir. Actually, we will create the. We have to make a developer. We have to make a database for that. After that, we will find them. Actually,
Okay,
sir,
you have to find.
Actually, sir, we have to make.
Yes,
sir.
You have to find the relevance of, I think, in order to find the NDCG value for each position.
No, sir. In future, I will do that. Till now, I applied only AP method and Topsys method. Actually,
Okay, I'm
for that, I have to make the my database from scratch.
Okay, any other question? Any more question?
36.
Okay, if not any other question, then we will move to the next participants.
I would like to invite our next presenter, that is the paper ID 351.
Yes, hello, ma'am. Is my
Your
slide
slide
is
is
visible?
no.
Is my slide is visible, ma'am?
Yeah, go ahead.
My name is Gorango Dwari. I am currently pursuing my PhD from the University of Jawaharlal Nehru University. My paper is paper ID is 351, and this title is clustering for global and local outliers. This is the contents, and now I will come to the background. I have done a literature survey on the paper. That is paper number 2 in the reference, which actually splits the problem into a series of sub problems, and they put some function approximator to each sub problems to understand or specialize the in a subdomain. This is basically a learning follows. This is a hierarchical learning theory which decompose the problem in a series of some problems so that we can learn from the each sub problems and we can fit into the next level of problem. So our in from this paper, our objective is to split the data set into a clusters so that we have a cluster for outliers only, and those clusters are the possible global outliers and the outliers which share the same place with the normal data instances are considered as a local outliers. Now I have a literature survey which is given by GAN and NG, which design an outlier detection based on which is an iterative method using the k-means clustering technique. And in that paper they give an additional cluster for outliers only, means there are k clusters for the normal data points, and there are one cluster for outliers. And the second paper is by the Gupta et al, and he also proposed the k-means clustering method. The goal is to cluster a set of data objects to minimize the variance which are assigned to the same cluster with including a small set of data objects, and these small set of data objects are the outliers. Now I will come to the problem description. Here our objective is to find the hierarchy of outliers, means hierarchy in global and local level, and our concept is like that. The clustering technique which does not forcefully include all the data objects, means the isolated data objects, and means clustering technique does not forcefully include all the data objects, and those data objects are the possible outliers. And here we will implement the hierarchical clusters, because k-means clusters try to make clusters of same size, and so that's why here we have we implement the hierarchical cluster for hierarchical cluster to find out the hierarchical level of outliers in a global and local level. At the very first, we perform the hierarchical clusters of data and create two clusters, and then perform the isolation for to validate the outlier in both the clusters. And clusters with a few isolated data points are considered as a global level of outlier, and rest of the identified outlier are sharing the same space with the data points, and they are considered as a local level of outlier by definition. Here we can see through the visualization that there are few data points which is in a red color, they are completely different from the blue color, and they are creating actually the level. Level means level of global level, and few data points which are sharing the same space with the normal data instances are the local outlier. And we actually implement this experiment on a page block data sets, and which and there are on an average there are 548 outliers, and out of that 20 outliers are and 20 outliers are separated by the by I mean we have we get two clusters, and 20 outliers, and there is cluster B which has only the outliers, no inliers. Means these 20 outliers are completely different from the normal instances, and they are creating their own space, own space, and that's why they have their separate clusters of outlier. And these 20 outliers are the global outlier by definition, and there are 528 outliers which are the local, which by definition is a local outlier, and they are sharing the same space with the local outlier, as because and that is validated by the isolation forest. So now conclusion. We have proposed a clustering for the global and local outlier to do detections of outliers and identify the hierarchy of outliers. This approach consists two parts. Basically, first is a detection of the likely candidates at multiple level, hierarchical learning, followed by the validation of the presence of the outliers in the hierarchy using the isolation forest. And that there is a hierarchy in the outliers, and the excluded data objects which are segregated from the prime clusters are the potential candidate to be the outliers. So we can extend our approach further into hierarchy of outliers in a multiple levels. To find out the hierarchy of outliers in so many levels, if in exist. This is our next level of work where I am to do. And this